Hello, this is Zach Knoll. This is for CIS 210 data structures, um, week 8, and really slow linear searches. So for this week, we had to use that ridiculous list of numbers and without sorting it, produce the range, most common, least common, an unordered set, or just a set because sets are unordered, and then how long it took us to do this. Assuming you meant runtime of the program, because maybe an hour each for me to write them, so to speak. But yeah, so I pull from my handy dandy list for class, and I'm going to try to, hopefully this works, I'm going to run it a little bit, pause the video while it runs, because it takes 15 minutes, give or take, and then resume it so we can look at the results. So everything's turned on except for, this is just checking the print function. And this was really just to test things as I was going. It's up to the full size right now, but it was originally just testing, like, it was printing out just 10 letters at a time, or numbers, just to work with. And, yeah, obviously I did everything in a much smaller list, and then once it worked, I just expanded it into the 99,999 integer list. So, let's run. So as you see, it's going to start up, and it's actually going to do the duplicate list first. And I originally just had it spit out the whole list at once, and I didn't really like the way it was doing it because it seemed like it was slowing everything down a lot. So I ended up just iterating it one more time, so it just run one after another down here, and it makes everything just kind of run smoother in the output. And then at one point I had it dumping into a text file as well, but that kind of defeated the purpose of showing how long it took, because it did it rather quick. I mean, well, yeah, it still went pretty quick, just this output took a while. So as you see, this is going to go for a little bit. We're at 1900, and it goes up to, like, I think it was like 56,000 or something. So I'm going to pause right now, and then when this sequence finishes, I'll resume and show you where we're at with the next part. So yeah, see you in a minute. Alright, so we're back. Our list is made. There's no duplicates in it. As you can see, it's down in the 56,000s. And it's all there. You can check each one if you want. I'm not going to. I kind of just trust the system. So that took 189 seconds, as you see. I didn't bother converting any of the time around. We know what seconds look like, so it's easy enough. It's not like we need it to be fancy. Doing the range is a really fast, almost instant process. As you can see, 0.02 seconds spits out the maximum, the minimum in the list, and then just subtracts and grabs the range. Right now, the program's working on finding the most common and least common. And I actually tied these into one function to help speed it up a little, because as two separate, it was quite slow. I mean, it is still slow. It's going to take like another 10 minutes, but that's besides the point. So yeah, this one's the longest one, as you know, because it obviously has to go through the list like a billion and one times to make sure that nothing's a duplicate. So yeah, I'm going to pause this, and we will return at the end of it. Alright, welcome back again. So now everything's done. Most used, least used, how long it took each one, and then the entire operation from start to finish. So, as you can see, this one today actually, because I've got some other stuff running right now in the background, took around 18 minutes. So, it's incredibly slow when you do it this way. It works, but painfully slow. So yeah, have a good one.